Alright, so this is day 67. We're going to continue on what we learned yesterday, but we're going to be combining a couple things, okay? So the one thing we're combining is solving by factoring. We already know how to factor. We know how to do that. They're going to be a little bit harder today, but we're going to continue on the idea we talked about yesterday, where y is equal to... Nope.
y1 is equal to y2.
Yeah, y1 is equal to y2, meaning like these two equations are equal, or y is equal to y, really. Okay? So when if we know that, then we could check our work always, and we could graph anything we want that has solve in it. So why does this work? Remember from a few weeks ago, or even in Algebra 1, systems of equations, y equals to 3x plus 4, and then let's say you had y equals to negative 2x plus 10. Well, you could solve this by substitution, because we could say that this first equation, the y is equal to y, right? Would you agree that this is logical? Is y equal to y?
Yeah.
Yes or no?
Yeah.
Is this logical? Yeah. You see how there's a y here? Well, let's just make these two equations equal to each other. Let's say that this first y is actually equal to this right here. So we'll just say 3x plus 4, right? And the second equation, negative 2x plus 10, for the second y, well, we're going to substitute for that. Okay? And we could solve this, right? Remember this a few weeks ago? And where's the answer? Where are the lines? Intersect, right? So today we have equations, right? We start with equations. Why can't we think backwards and go backwards just to think like, oh, it's equal to y is equal to y, right? We could think backwards. So does that logic make sense?
Yeah.
We're going to apply the logic to what we're doing today. All right, so steps are the same as yesterday, but if you are on the video in your notes, you should copy this second step down, okay? So please pause the video here and write that down. All right, so here we go. Numbers 1 and 2. I'm going to do numbers, we're going to do a couple more as groups today also. So eyes up here. So up here it says solve. So when I see a solve problem, I'm thinking, what is the value of the variable? In this case, the variable name is x. So I'm thinking, what is the largest exponent of x? 2, right? So it's going to have 2 answers, right? So, and it's quadratic. So the first thing I want to do is isolate all of my variables and all my terms on one side and set everything equal to 0. So we did that. Then we're going to factor this left-hand side right here. So I want to take 5x squared and negative 4 multiply. It's going to be negative 20x squared. And then I'm going to start breaking this apart. And I think, what times what is going to equal to negative 20x squared, but adds up to positive 1x? Well, it's going to be positive 5x minus 4x, right? 5x minus 4x is 1x, and 5x times negative 4x is negative 20x squared. So since that's the case, we're going to factor by grouping now. I could factor out a 5x here. We got x plus 1 here, right? Because 5x times x is 5x squared. 5x times 1 is positive 5x. Over here I could factor out a negative 4. So we got negative 4 times x is equal to negative 4x. Negative 4 times positive 1 is equal to negative 4, which is all equal to 0. Both of these terms now, we got 2 terms, one here and one here. So on both of these terms I see x plus 1. I could factor out x plus 1 here and here. And then we know x plus 1 times 5x is going to be equal to that first term. And then x plus 1 times negative 4 is equal to the next term. Bring that down. Now we're at a point we can use the zero product property from yesterday. We have 2 factors here, right? So I'm going to take each factor. Since they're both equal to 0, I can make each of these equal to 0 separately. So x plus 1 is equal to 0. And then we have 5x minus 4 is equal to 0. And so we can subtract 1 on both sides here. So we get x is equal to negative 1. And then we have 5x minus 4. We're going to add 4 to both sides here. So we have 5x is equal to 0 plus 4, which is 4, divided both sides by 5. What's 4 divided by 5? I could do a decimal, but I could just leave it as a fraction, 4/5. Okay, that's the answer. Okay, these are your two answers. So, did I get two answers here? Yeah. So, today is a little bit different because you're going to have fraction answers sometimes, okay? So, here's the step 4 now, okay? Can you all write down these two answers here on step 4, please? So, remember that y is equal to y. Remember the original thing I was talking about? Y is equal to y. Now, step 4. Do you all agree that y is equal to y? Would you all agree that y is equal to y? So this whole left side should be equal to the whole right side, yes? So this whole left side we could say y is equal to 5x squared minus 4, and this whole right side we could say y is equal to 0. Does that make sense? So can you please also write down the original problem right here for me, these two equations? And we're going to go over to Desmos right now. I'm going to go over to Desmos. Here we go, check this out. I'm going to put these into my graphing calculator. What was the first equation? Y equals to what? 5x squared plus x minus 4. Okay, cool. And then what's the second one? Y equals 0, right? I got a blue line and a red line. Where's the answer? Where the lines what? Good. So they intersect how many times? Twice. Now look at my answers. I got -1 and 0 and 0.8. What do you notice about these points and your answers?
The x values are going to be the answers.
The x values are going to be the answers. Excellent. Just like yesterday, right? So it doesn't matter what the y is. The y is 0 because we said y is equal to 0, right? But the x answers, right, are the ones that say we have -1. X is equal to -1 here. And over here, x is equal to 0.8. Why does it say 0.8? Oh, right. Isn't 0.8 the same as 4/5? Yep, same exact answer, right? So should you get any of your problems wrong on this type of work? Nope. We can always check your work, right? Make sense? So whenever we see the word solve, get that graphing calculator out because we could use this logic here, this y is equal to y thing. Okay? So I'm going to go back to number 2 here. Number 2, we got 7n squared plus 8 is equal to 57n. Okay? So what do I notice here?
The 57n is on the opposite side.
Good. It's not equal to 0, so I want to subtract 57n on both sides. So I'm going to do this one much more quickly than the last one. Because I want to focus on the graphing calculator part. Okay. I got two numbers. They need to multiply to be 56n squared. I multiply the first and last term. Okay, and I'm going to rewrite this as 7n squared plus 8 is equal to 0. And I'm going to pick two numbers in the middle that are going to be equal to that. So it's going to be -56n and -1n. Right? I'm going to group these together. So here we go. I could factor out what out of this first two sets, or first two numbers? What? 7n, right? 7n times n minus 8, right? Second number I could take out a -1, right? -1 times n is equal to -1n. -1 times -8 is equal to that second term. I know I factored it correctly because I got two of the same terms here, right? I could factor out n minus 8. And I could factor out 7n minus 1. When I do that, I could use the zero product property. I'm going to get n minus 8 is equal to 0, and then I'm going to get 7n minus 1 is equal to 0. So I'm going to, over here, I'm going to add 8, which is going to be n is equal to 8. And over here, I'm going to add 1 to both sides. 7n is equal to 1. Divide both sides by 7. You got n is equal to 1/7. Okay, two answers, right? And if I look at my original problem, it's n squared, you see? So how many answers should I have had? 2. Okay? Okay, so what I'd like you to do now, we're going to write the original problem here and the two answers. Okay, we're going to go to Desmos to do the step 4. Please do that for me. Remember the original logic, y is equal to y. Do you all agree with that? Yeah. Okay, look at the original problem. This one is not equal to 0. So look at this left side. We're going to say y is equal to this whole left side here. Eyes up here, eyes up here. Y is equal to 7n squared plus 8. Instead of using n, let's use x. Okay, can we do that? And then the second one, y is equal to 57x. Okay? So I'm going to write that down and go to Desmos. Now that I'm in Desmos, I'm going to clean out my graphing calculator, and I'm going to put y is equal to 7x squared. I'm not going to use n because I'm going to use x. Plus 8. And then I got y is equal to 57x. Okay, what do you notice about my graph here? It's high, right? So I'm going to drag it. I notice there's a point here. Look at that. It's 0.143. Why does it say 0.143 for my x value here? They divided. What does that mean? You see how it's 0.143? Well, everyone go to your calculator. What's 1 divided by 7? Go to your calculator and type 1 divided by 7, or 1/7. What's it equal to again? Point what? 143. Do y'all see that? So it's just a decimal version. There's the connection. Now where's the second point? The first point's here. Where's the second one? How did you get that? Did you have to zoom out or drag it? Okay, so we have to zoom, right? So I'm going to zoom, right? This line right here, this orange one, if I keep going up, it's going to cross again. So I'm going to zoom out. And look at this orange line. It's going to keep going up here. And check it out. It's going to go all the way up here, and it's crossing again. Look at the second point. What's x equal to in the second point? 8. Isn't that the second answer we got? Cool. So, should you get any of your answers wrong when you do your solve problems? No. Let me show you one more way. Okay? Going back to number 2. Eyes back up on the screen, please. Okay. So, you all agree that up here this is the original problem, right? Yes? Now check this out. Would you all agree that this first line is the same thing as this third line here? Would you all agree that this is the same as this?
Yeah.
What kind of equations are there? I told you yesterday they are what kind? Equivalent or more equivalent? Equivalent equations? Okay, so if the first equation is the same as the second equation, let's go back into our graphing calculator and we say y is equal to this right here and y is equal to 0. Okay? Can we do that for me, please? Going back in there. Back to Desmos. I'm going to clear out my iPad or my Desmos graphing calculator. And I'm going to start putting my equations in. We got y equals, and we wrote 7x squared, so I'm going to put 7x squared minus 57x plus what? Plus 8. And the second one is y is equal to 0. Now, why does it look like it's like this right now? What do I need to do to get back?
Zoom out.
I got to zoom out or what? What's the button I should click?
Press the home button.
Good. Press the home button. Check this out. So I got a black line. Actually, change the black line to a different color so you can see it. Let's do orange line and purple. That's where the lines cross. Where do they cross?
0, 1, 4, 3, 8.
Good. Now, why would I have used this second equation? Oh, wait. One more question before that. Did I get the same answers for my x? Yeah, good. Why would I have used the second equation where everything was set equal to 0?
That's how it works.
Why would I prefer to do this? Didn't I get the same answers using it both ways?
Yeah.
It's faster. Why is it quicker?
Because you don't gotta automatically do that.
No. Why is this faster? What did you notice I didn't have to do on my iPad? Scroll, right? Did I have to zoom out to find the answers? No. You see that? Okay, cool. Sorry, a lot of stuff at once. Concepts coming together. It's kind of hard, right? Okay, cool. So that's the idea today. We're doing the factoring, and we're using our graphing calculator to check our answers, all right? So I'm going to go back to I'm going back here to numbers 1 and 2, okay? So I'd like you to do it because we all get kind of tired in our seats. I want you to talk, so I would like you all to stand up, find a new person, and just number 2, the whole problem. You need to have one of these in your notes. Number 2 is a good one in your notes. Okay, and number 2 is really about how to do it factoring. Like if we're doing a test and you're not allowed to use your calculator, you need to know how to do this without a calculator, okay? Oh, here we go. Numbers. Can I move on to 5 and 6? Yes? I know we're jumping straight there because I think you could do it. If you want to do 3 and 4 on the video, you can. But let's go to 5 and 6. Here we go. 5 and 6 are the groups. I'll give you about 5 minutes, okay? Can we do 2 problems in 5 minutes? Okay, so I expect a lot of math chatting and a lot of working together, but you're all working also by yourselves in your own notebook papers also. Okay? 5 minutes. Go. All right, so I'm going to reveal the answers to you. So on number 5, you should have broken it down like this. And, of course, when you do that, let's do this a little bit. It's going to look like this. Factor in x plus 6. And then here's your 2 answers, right? Notice how I skipped a step right here from x plus 6 to here. That's okay. You'll start seeing a pattern of how you're supposed to work it out. Okay, number 6. Ready? Number 6 is the following. You're supposed to move everything to one side, and then you multiply. Everything's supposed to be equal to 200 squared. This is the easier one, apparently. So this is
okay. I was along the right track. I just didn't know how to do it. Sweet.
raise your hand if you got both of them right. Yeah, good job. Okay. Now I will say, like this is all done by hand. I know you could check your work on the computer or on a graphing calculator, or you could use an app. What was the name of the app again? Math what? No, the one that he showed. Mathway? Cool. So Mathway, you could check your work on these, or Math, Photomath, or whatever you want to use. Okay? But that concludes the lesson for today. I'd like you to discuss these 3 questions. This third one's different from yesterday, but I will be calling you on all 3. That concludes the lesson. Go.